Okay, question 11 says in the diagram below, C and D represent two drones on the ground. The drone at C has a flight path modeled by f of x, which is the parabola here. The drone at D has a flight path modeled by g of x, which is the straight line over here. CD is 7 meters and AB is 2 meters. We are not told the value of M. We are not told the value of Q. But yeah, that's about it. And then A says if point E is above C, directly above C, calculate the length of EC. Show all you're working. So we need to get the length of this. In other words, if you don't want to do any calculus, then we are basically trying to find the value of y here, because that will represent the height from C to E. So in order to get that, we need to work backwards. We need the x value here. Needed to get the x value there. That's the same x value we have at C. And can we get the x value at C? How can we do that when we don't know Q? So f of x is equal to minus x squared plus 2x plus Q. If we knew the value of Q, then we could set this equation to 0 and solve for the intercept at C. But since we don't know Q, we have to try and find it first. How can we find Q? Q is the y-intercept. And what else do we know about this? We are told that the y-intercept for G is 5, but the distance between B and A is 2. So if from origin to B it's 5 units, then from O to A it will be 5 minus 2, which will be 3. Which means the value at A, the coordinates for A, are 0 and 3. Which means the value of Q is equal to 3. We can make that substitution and equate this to 0 and start solving. So we're gonna say f of x is now minus x squared plus 2x and plus 3. Then we equate this to 0. We can move everything to the other side so it becomes positive. Positive x squared minus 2x minus 3 is equal to 0. Open up your two brackets, equate them to 0. You have x, and here you're gonna have x, the values of x is of 3, that'll be 3 and 1. So minus 3 plus 1, we're gonna have x is either equal to 3 or x is equal to minus 1. These are the values of our x. These are our x values for the intercepts. So this one is most likely to be the positive one since it's on the right side of the y-axis. So the positive one here is 3. So now we know the x value here. So x is equals to 3. We can update E, 3y. Now we need to know the y value at E. We can just substitute the value 3 into the formula for G. But what else is the problem is we don't know the gradient of this line of G. So we first need to compute the gradient before we can get y. So currently we have g of x is equals to mx plus 5. To get our gradient, we need 2 points here. What other information we have is that the distance between C and D is 7. And now we know the distance between O and C is 3. Therefore, from O to D, that would be 10, meaning that the x value there is 10. And that's 1 point on the line. The other point we know is the intercept, which is 0 and 5. And if we compute the gradient using these 2 points, we're going to have 0 minus 5 over 10 minus 0, which will give us negative a half. So negative a half times x plus 5. That's our formula for gx. Now we need to find the y value, which is g of 3. And we substitute into x, 3 plus 5. And what do we get from this? So that will be minus 3 over 2 plus 5. And you can multiply both by 2 to get y is equals to 7 over 2. So this is the y value, and this will also correspond to updating E again. That was 3 and 7/2. So it means EC is equals to 7/2.